In this video, we're going to use the sine rule to calculate the length of a side. Just a wee intro into the sine rule. Here I've got a triangle drawn with all the sides and angles measured. These have all been done to the nearest decimal place. I want you to notice a few things. Hopefully you can see that 94 degrees is the biggest angle. Do you notice that the side across from the biggest angle is the longest? The second biggest angle, 54 degrees. The side across from that angle is the second biggest. The smallest angle, 32 degrees, the side across from it, is the smallest side. This in essence describes what the sine rule actually is. The biggest angle is across from the biggest side, the smallest angle is across from the smallest side. I'm going to rub this out here. I just want to talk about a wee brief intro before we get going. In order to use the sine rule, we label the opposite sides of triangles. So do you notice that this angle at the top here, labelled B, the side across from it, we would label that side lowercase b to show that relationship. Similarly, the side across from angle A, we would label lowercase a. The side across from angle C, we would label lowercase c. When we're working with the sine rule, we always label the sides. I'm not going to go through the derivation of the sine rule, but essentially the sine rule is given as this: a over sine A equals b over sine B is equal to c over sine C. This is given to you in your exam. This is on your formula list. This is really important though, so can I ask you please to highlight this, bubble this, make this important. Just want to talk briefly about where this has all come from. So hopefully you can see that we've got lowercase a, lowercase b, lowercase c. That is going to be corresponding to the lengths of the sides. And here we've got capital A, capital B, capital C. Those are going to be corresponding to the sine of these angles. Okay, so once we've got, or now that we've got this formula in place, we can now go ahead and use this formula to solve some problems. So I'm going to ask you to pause the video here and to copy this down. In example 1, we want to calculate the length of AB. So AB is the line segment joining the point A to the point B. So it's this point here. We want to work out this. And when we want to work out something, we usually denote it as X. Okay, so a few wee things. We know to use the sine rule here because we have pairs of information. We have this angle B here, and we know the side across from it. We want to work out this side, and we know the angle across from it. We have those two pairs. So because we have those two pairs, we know to use the sine rule. Before we go ahead and calculate the value of X, it's always good to have an idea of what your answer should be roughly around. Do you notice that 85 is the biggest angle in this triangle? So therefore, because that's the biggest angle, 5.5 will be the biggest side. So we expect our angle to be smaller than 5.5 because it is opposite a smaller angle. Okay, so our first step when we are working through this is we label the opposite sides. The side across from angle A is labelled lowercase a. The side across from angle B is labelled lowercase b. The side across from angle C is labelled lowercase c. Now that we've labelled our sides, we're going to write down our formula. Once again, this is given to us on our formula list. A over sine A is equal to B over sine B is equal to C over sine C. Okay, so let's look at what we know. We know, I'll label it here, we know the length of side B. So I can tick that length there because I know it. We want to work out the side length C. So I'm going to put a wee question mark here because we want to work that out. We know all three angles. We know angle A, angle B, angle C. So we can quite easily evaluate angle A, angle B, angle C. Okay, so we have got three fractions here. We are going to eliminate one of them. You need to be able to identify which fractions we are going to use. We are going to use the fractions that have two ticks and a question mark and a tick. So do you notice that this first fraction only has one tick? So we omit that. We are going to be working for the remainder of this question with this section here. Okay, so let's proceed. What is lowercase b? Well, it's 5.5. So 5.5 over sine of 85, and that's equal to x over sine 47 degrees. Okay, we want to work out the value of x. So we want to make x the subject of the formula. Here's x here. In order to get x on its own, it's currently being divided by a value. Sine of 47 is just a number. Do not write this down, but see if we had an equation x divided by 2 is 8. Well, to work out that value, we would multiply both sides by 2, and we would obtain x equals 16. So essentially here, to isolate x, we are going to multiply both sides by sine 47. That's just a number. I'm going to multiply this side by sine 47. I'm going to multiply this side by sine 47. We do that because it then makes x the subject of the formula. I'm going to rewrite this around the other way, so we've got x on the left, so that's going to be x is equal to, I've got sine 47 times 5.5, I'm going to write that as 5.5 sine 47. It's just going to multiply the numerator there, and that's over sine of 85. And typing this into a calculator, 5.5 sine 47, close the bracket, over sine of 85, close the bracket. When we do that, we get 4.04 to 2 decimal places. To 2 decimal places. Okay, so let's have a look here. So this side here has length 4.04, and that is indeed smaller than the 5.5 that we were expecting. That was example 1. Example 2, one more example. Calculate the length of PQ. Well, in this example, it's going to be that guy there. So let's label the opposite sides. So the side opposite angle P will be lowercase p, the side opposite angle Q will be lowercase q, and the side opposite angle R will be lowercase r. Before we go any further, do you notice that we have one of the angles missing here? We can easily work that out though, because we know that the angles in a triangle add up to 180 degrees. So to work out angle Q, we could simply add 55 and 23 together and get 78, and then subtract. And we'll find that this angle up here should be 102 degrees. Okay, so we want to work out R. And we know to use the sine rule here because we have matching pairs of information. I want to work out this side. I know the angle opposite it. I have this side, and I know the angle opposite. So that's a wee clue to use the sine rule. Instead of it being A over sine A in this instance, which is on your formula list, our vertices are labelled differently. It's not A, B, C, it's P, Q, R. So we just need to adapt our sine rule slightly. It's going to be P over sine P equals Q over sine Q equals R over sine R. Let's tick what we know. We know the length of Q. We want to work out the length of R. We know the angles P, Q and R. we will use the fractions that have 2 ticks and a question mark and a tick. So, and once again, we're going to omit this one. It's not always going to be the first one, it just depends on the situation. Let's substitute in our values. 3.62 over sine of 102 is equal to x over sine of 23 degrees. We want to make x the subject of the formula. At the moment it's being divided by sine 23. So in order to get x on its own, we will need to multiply both sides by that sine 23. Just do sine 23 multiplied. We do that because these will simplify. So I've got x on its own on the right. I'm just going to rewrite that on the left. I'm going to have x is equal to sine 23 times 3.62. We're going to write as 3.62 sine 23 divided by sine of 102 degrees. On our calculator, 3.62 sine 23 divided by sine 102. Remember to close those brackets, if you don't, you'll get a math error. And when we do that, we get 1.45 to 2 decimal places. In this case, our units are not centimetres, they are metres. Okay, so there are 2 examples on how to calculate the length of a side using the sine rule. One we think here, our angle is the smallest in this triangle, so our side here we would expect to be smaller than 3.62, which it indeed is. Okay, so once again, this is a skill you can pick up a lot of marks in, particularly if it's in a paper 2. Thank you very much.